Hello everyone, this is our video explaining the function of the calorimeter, linking it to the topic seen in the class. The calorimeter measures the temperature of heat that is produced, and this is a topic of thermodynamics. Okay, to explain it, we need to cover the main topic such as what is the system that uses the calorimeter? This one we see here is a container with a reaction inside and thermometer. This is an open system because it is exchanges mass or energy from the environment, and thermometer measures the heat emitted by reaction. But being an open system alters the reaction because the heat is going in and outside, and the energy is not conserved. That is why this system doesn't work. Therefore, a closed system is a net which does not allow energy to come out and heat from the surroundings. The open system is put inside the closed system and the thermometer goes inside the water because if it were inside the reaction, this interferes. Water allows to measure the heat emitted by the reaction, but this system is not as efficient because it is not so resistant and allows it to exchange energy from outside. It was put in an insulated system. This allows no heat or mass to come out or enter, and the energy within it is conserved. The increase in water temperature can be measured, can be associated with the internal reaction. Also, what surrounds the reaction is an adiabatic process which does not lose energy or mass and allows the temperature to be measured without any interference from the environment. For that reason, it's a good system and process. To continue with the uses that are part of the operation of the calorimeter, the zero law of the thermodynamics is taken into account. It seeks a balance between three bodies, which for the calorimeter we have the reaction, the water, and the container, which are going to have a thermal balance between the three, also taking the specific heats of each body. Finally, the first law of thermodynamics will be related that says energy is not created or destroyed. It seeks the conservation of energy. If there is no transfer from the outside, the law determines that the internal energy of a system increases or decreases when heat or work is transferred to it. If the system has rigid walls, pressure volume, work cannot be performed and the system walls are adiabatic process.
Okay guys, the next part of the subject is calorimetry. It's used to measure the heat of the reaction. It is a crucial part of the thermodynamics. To measure the heat of research, the reaction must be insulated, so that no heat is lost to environment. This is accomplished through the use of the calorimeter, which isolates the reaction to either contain heat. Using calorimetry, it is possible to calculate the amount and heat gained by any part of the reaction. That is related to the heat capacity of the substances. Heat capacity is the amount of energy Q required to raise the temperature by 1 Celsius or 1 Kelvin. To calculate the amount of heat released or absorbed by reaction in thermodynamics of delta T, The quantity of total heat is capacity of objects. Okay, the next part is the capacity of heat. The total heat capacity of an object can be decomposed into one of two sequence relationships, either basis of mass, C equal m at Celsius Sp, or basic number of moles of the atom or molecules in the object is C equal n at Cp. Well, theoretically, the Q produced should the quality length to Q reactions, because the amount of heat gained by one substance should be equivalent to the amount lost by another. However, the calorimeter also necessary for calculation and result in the following equation: Q reaction plus Q produced plus Q calorimeter equals 0. The other form to write this equation is Q cal equal minus Q lead plus Q water. And finally, the example is if 150 grams of lead at 100 Celsius were placed in a calorimeter with 15 grams of water at 28.8 Celsius, and the resulting temperature of the mixture was 22 Celsius. What are the values of Q lead, Q water, and Q coal? The specific heat of water is 4184 joules per grams Celsius, and the specific heat of lead is 128 joules per grams Celsius. And finally, the solution is the next. Currently, we know that M open the brackets mass close the brackets is equal to 150 grams, and T1 is equal to open the bracket initial temperature close the bracket is equal to 100 Celsius. T if is equal 28.8 Celsius. CSP is equal to open the bracket specific heat of lead close the bracket is equal 0.282 seconds of grams Celsius. For the water is M is equal to 50 grams, T1 is equal to 22 Celsius, TF is equal to 28.8 Celsius, and CSP is equal to 1184 joules per gram Celsius. Q is equal to mCSP delta T. Q lead is equal open the bracket 0.128 joules per gram Celsius close, and again open the bracket 150 grams close the bracket open again 28 Celsius minus 100 Celsius close the bracket is equal to minus 1.37 at 10 joules, and the water and the Q water is equal to open the bracket 4184 joules per gram Celsius close the bracket open the bracket 15 grams close the bracket open the bracket again 28 Celsius minus 22 Celsius close the bracket is equal to 1.42 at 10 joules. Q cold is equal to open the bracket Q minus lead plus Q water close the bracket. B point Q open the bracket cold